So this evening, we are honored to host Miss Aleksandra Scalco. Miss Scalco is a CSEP and recently gave a presentation at an Incose Critical Infrastructure Protection and Recovery Working Group just a couple of months ago. And so another member of our chapter brought her presentation to my attention, and I thought, hey, yeah, I think there's a lot of members in our chapter who would be interested in hearing about that. So I hit her up, and Ms. Scalco, she is currently an engineer with the Naval Information Warfare Center Atlantic, United States Department of Navy, of course. She has obtained a Master's of Engineering in Systems Engineering from Iowa State University and holds an MBA from the University of Phoenix and a bachelor's degree from the University of Missouri. She is also currently pursuing her PhD degree in Systems Engineering at the Colorado State University. From 2012 through 2016, she was an information system security designer and client advocate with the National Security Agency, local here. She is the author of several articles about cybersecurity for control systems. Her research interests include cybersecurity of control systems, digital transformation of cyber physical systems and control systems, engineering of cybersecurity capabilities for context sensitive. And folks, can you mute? I hear some background noise. Thank you. Operational technology software defined networking. And the development of tactics, techniques, and procedures using software orchestration to achieve cybersecurity for control systems. Her awards and honors include membership by invitation of the 7th cohort of the International Council on Systems Engineering, Institute for Technical Leadership, and the NSA CSS Crescent Performance Award for Mission Excellence in 2013. So with all that, I'm going to now turn the virtual podium over to our speaker. And if everyone could turn off their video and mute themselves, that would help with the presentation.
Oh, thank you so very much, Clinton, for that kind introduction. Thank you, Jeffrey Burlett, for inviting me. And it's good to see David Aldridge and Dave Flanagan. And thank you, Deborah Harris, for sharing the information you did on what your chapter is really stepping forward and leading for STEM. It's just so incredibly important and really value that. So let's see if I can share my screen here. So thank you very much for helping me, for inviting me. Really appreciate the opportunity to share systems engineering approaches with fellow Incose members. This is a little bit about the case of control systems cybersecurity capability. So cybersecurity risks are all part of an overall system risk management process that we as systems engineers look at. We look both from the qualitative as well as quantitative methods. And we do have tools available for risk identification, risk analysis, and cost analysis. After all, that's what we do as systems engineers. This brief is based on a short, abbreviated cost-benefit analysis that's loosely based along the lines of a recent joint capability technology demonstration, MOSAICS, as the control. So that's where we're looking at. That would be the control system to support cybersecurity capability for control systems. I'd like to take a step back and just kind of give a little bit of the landscape. As we've seen in the news information about cyber events on control systems such as water systems that I'll touch a little bit on in this brief. I'd like to kind of pull out, especially since Deborah commented on the internationalness of our Incose membership, and that's we have in Ethiopia, the Grand Ethiopian Renaissance Dam, a fantastic multi-billion-dollar engineering project that's finally coming to fruition in Ethiopia that's really going to be beneficial to the citizens of the country in many ways. economic ways and social ways. And that one would think is a very good thing, right? This big grand Ethiopian dam. In the first year, it retained 4 billion cubic meters of water up to the height of the lowest point of the dam. It's a hydropower dam, $4 billion of investment. And at the same time, its neighbors have gone to the United Nations Security Council and asked the United Nations Security Council to step in because the neighbors are equally dependent on the Blue Nile that Ethiopia is now using as part of its dam. So I kind of share that in the sense that where, as we as systems engineers are designing systems, we're looking at the functionality of the system that we'd like for it to achieve. We're looking at the maintainability, the sustainability, and then there's also a piece in our Incose chapters that we do have a chapter, for example, on the socio-technical, which is what are the other interfaces beyond the functionality of the system. And then I'd like to draw your attention a little closer into the United States, and we're looking at the Hoover Dam and some of the climate change and the effects that we see ongoing on the West Coast and some of the dams potentially coming offline. And that's going to affect us all as citizens, whether we work for the government, whether we are just citizens of municipalities. But a Hoover Dam coming off of line or the Oroville Dam that feeds into the Hoover Dam affects the portable water accessibility. It affects businesses. It has economic impacts. We really don't have those systems engineered solutions for longer term solutions of how to address that. Going back to GERD, or the Grand Ethiopian Dam, the GERD has already had cyber attacks on it, allegedly. So the perpetrator allegedly was from one of the neighboring countries and making threats against the dam. So we can see that there's a lot of drive and tensions that we as systems engineers need to be able to model out and understand. And that's this business case now is a little bit about how we identify what we can do to mitigate some of those risks and what is being done. In the United States, the government has invested more than 20 million to buy down the risk in the development and demonstration of such a capability. That was the MOSAICS Joint Capability Technology Demonstration. It was successfully demonstrated in a military utility assessment in August of 2021. So I'm going to connect some of that capability demonstration to a real world example of a recent ransomware case study of the Colonial Pipeline that we witnessed from 7 to 12 May of 2021. And the way that I'm going to approach it is saying, what is the cost of not investing in these MOSAICS-like capabilities, as well as I'm going to go over the actual cost of such a control and what the expected labor costs are. I'm looking down here on my computer because I'm going to open just this morning. There was in breakingdefense.com an article about Colonial Pipeline hack, and the headline read, "Colonial Pipeline hack shows the perils of ignoring cyber vulnerabilities." And that was our Secretary of Defense really talked about that ransomware attack on Colonial Pipeline. And while it didn't directly assault the military networks or other infrastructure, how it's really starting to raise some alarms about the vulnerability and the fragileness of our economies and environments and dependencies on some of the critical infrastructure. There we go. So some general principles of cybersecurity: that risk equals probability and consequences associated with a threat agent exploiting a vulnerability to do harm. So no system can be perfectly secure. The goal is to mitigate the prioritized or the right risk in the right order or priority order to achieve an acceptable residual risk while leveraging or incurring acceptable costs, right? All in the eye of the beholder and what the operational impacts are. So this requires risk identification and an analysis for an effective strategy, which is what we do as systems engineer. And the bottom line is there is a cost for not investing in cybersecurity when it comes to control systems. What you see here on the slide is an average cost for a data breach in 2020, but that's a data breach. That's not the average cost for really the impacts of a physical system. These are systems that control our physical world and can potentially lead to severe consequences that I'll touch on in a moment. So I'm going to take a little bit of a step back as well through the timeline of where we came from. We're all most familiar with IT systems at the enterprise level. And the path for near real-time solutions for IT enterprise really started from the 1980s through 2000. The IT industry focused on inventory and asset management, then configuration management, and then identity and capability. When we see in the timeline, we see a couple of points of inflection, or one might say disruption, such as when the electronic manufacturing industry came to arise, and that EMS industry could really be a disruptor, where we went from single OEM, original electronic manufacturers, moving or outsourcing component parts to the EMS industry. On the positive side, it really drove down the costs, and it really raised some of the capabilities that we were getting in our IT components. But it also led to the commoditization of IT components, right? We also see the rise of cloud computing, and then later secure orchestration and response. And then we're moving towards that software-defined networking capability that we'll be seeing. At the same time, the control system path to near real time is a little bit different. The revenue today in the control system industry is still primarily generated from hardware sales. By contrast, this is where the IT industry was in the market space in the 1980s. So think about that. In 1980s, that's where a control system is in comparison to the IT industry. So the government-led initiatives such as MOSAICS is trying to advance the current control system capability to expand to hardware use and basically buy down the risk of that early design and development, the early S&T, the science and technology work. The MOSAICS Joint Capability Technology Demonstration demonstrated new capability within 3 years with $20 million, which is a significant investment, but it basically advanced the same type of capabilities to the point that it took IT more than 50 years to achieve. So the world's first publicly known digital weapon that targeted equipment and operations in the control system physical world was known as Stuxnet. If you're familiar with that, that was in 2020. Stuxnet specifically targeted industrial software and equipment. Then we had Night Dragon, Flame was used. Then we had a series of intrusions targeted natural gas line. We saw Shamoon in 2012. We saw more brute force attacks in 2013. We saw an attack on the New York Bowman Dam. And then in 2015, a coordinated attack on Ukraine power utilities cut power to an entire population. And I'd like to point out that was also in the winter. And then earlier this year, we saw the Oldsmar, Florida water treatment plant where someone tried to poison the water supply of a population in Florida, United States. Now, there are approximately 15,000 residents in Oldsmar, Florida. And a hacker gained access through a vulnerability in the water treatment system's remote access system, and then attempted to increase the amount of sodium hydroxide or lye to poison the population. Thankfully, in this case, a supervisor caught the intrusion and reverted the unauthorized changes. But it's important to point out that the intruder was reportedly active for less than 5 minutes, and that there are more than 148,000 water supply systems in the United States, and virtually all of them rely on remote access, and most of the operations are unattended with 24/7 remote access. Most have not separated their IT systems from control system functions, such as the safety systems. So that starts to paint a picture of where there is a tremendous opportunity for systems engineering processes and practices to be applied to our critical infrastructure in the commercial world. Clearly, with the Department of Defense, we're also very interested in the security of not only water, but power, utilities, fuel that we fight with, and any of those capabilities to project force. That's the DoD mission. But for the commercial industry, we also have a very important relationship with the critical infrastructures. So risk management, I'm going to catch up over here. So risk management seeks to select controls to treatments based on cost-benefit ratios. There has to be a case for an affordability of a control, as well as the effectiveness against the most significant risk. The ultimate goal is to reduce the attack surface to a feasible minimum. But the impacts of no control system cybersecurity is a potential loss of mission, as I mentioned, for the Department of Defense. For a commercial sector or a commercial asset owner, potential of injury or loss of life in a power utility. They're always very highly concerned of safety of personnel, very concerned about potential for arc flash and the potential of harm to life. There's the economic impact, which I'll go over a little bit with the case of the Colonial Pipeline. And then there's the social undesirable impacts that could be potential, such as the loss of public confidence. So the risks can be high. As systems engineers, we really have to look at that system acceptance is when the cost of the countermeasure exceeds the cost of the risk. And understanding within the systems that we design where that cybersecurity vulnerability is, which is not necessarily how some of these legacy systems have been originally conceived of and designed for control systems, such as water systems, wastewater. In Maine recently, there was some wastewater spill, there was some damage that was caused to environment. So there's also going to be some potential legality consequences on system owners. So really we go back to what is the impact of no control system or cybersecurity for control systems. Preparation is absolutely crucial in response, and currently there's no compass for these context-sensitive critical infrastructure dynamic classes. So we're still in any kind of meaningful way so that systems engineers can address the systems while best practices, guidance, and standards and policy catch up. Approaches differ by sector, such as chemical or government facilities, or subsector, such as education, event facilities, or segment, such as government or commercial. Now, one of the things that we do have is out of the Joint Capability Technology demonstration, one of the artifacts or leave-behinds is that development of a reference architecture, or an architecture that can be reused, not only for government purpose, but also commercial purpose. That's going to be shared out with public distribution A for the requirements, as well as some of the high-level architectures of how you can secure one of these mission-critical control systems or critical infrastructure. That MOSAICS capability can be generalized into different sectors using that reference architecture. Currently, the DoD CIO is looking at using the reference architecture that came from MOSAICS in an appendix or Appendix D for control systems. That's currently in review, and that'll be offered out for reuse across services, across other entities in the government, as well as commercial services. And the data acquisition input can be from any control source, whether it's power, water or wastewater, fuel, or a facility-related control system using the sensors as required by the specific sector. MOSAICS value proposition starts with using all COTS, and it's intended also to be an interchangeable based on whatever site is being used. So it's not any one vendor specific, it's a framework. This is a part of that case study of the MOSAICS JCTD. What the JCTD did was really come down that infamous, the left-hand side of our systems engineering V, the conceptualization, the requirements analysis, the functional definition, physical definition, design validation. Now we're really looking at that valley of death in that systems engineering V, where we're moving from the JCTD advisory role to a command and control role. The Navy is leading forward and is piloting the first MOSAICS JCTD, but it's also really looking at sharing that out with other services. And the spiral for the V occurs at each site within a sector, and there is the reuse, but this is where the systems engineering or guidance, such as the Incose, CBOC, is really going to help, because it's a systems engineering process that's going to occur again each time this capability is applied to another sector, such as water. In the case of MOSAICS, the first site was a power site or power substation distribution system. So there are multiple values of death that we need to be aware of as we're coming across, but it's going to be the systems engineering applied to one vertical and then moving or transitioning to one of the other 16 sectors that's identified by Department of Homeland Security. So the overall security strategy for the control system is to leverage segmentation, complemented by principles of defense in depth and a zero trust network. Most of our mission or control systems that we see for critical infrastructure tends to be very flat. The objective is, I'd like to get information about the Oldsmar, Florida water system just very quickly and efficiently and in the least cost prohibitive way possible. So they're very flat structures. They're intended to be in existence for a long time. And we really have to start looking at putting in the same type of principles, such as segmentation or defense in depth, as we would with any other systems, particularly because of the level of consequences with not having any. So here we see an operational flow of how the detailed design might be as we refine the plans and the specifications and our estimates are being created. So these are the input and output flows between some activities as just an example. I'm going to start getting now into this part of the return on investment now that I've given some of the background. So service level agreements are an engineer's best friend. So what are the allowable downtime and unavailability? So just looking at a potential of not being able to access a service or a product for 5 days, that puts you in an uptime or availability somewhere between 98, 99%. So that's all well and good unless you are on the receiving end of the 5 days down. So I'd like you to focus on those 5 days for just a moment, because as a consumer of something such as fuel, I'd like availability of gas in my neighborhood to be somewhere upwards of 99.9%. And we're going to get to that in the case study for Oldsmar as well. So I'm aware of the DoD Annual Energy Management and Resilience Report, the AEMRR that you might be as well. In that, the utility outages are reported. However, they don't actually show any cybersecurity relationship to an outage by service. In this case of Oldsmar, we're going to get back to that 5 days. But if infrastructure itself is worth $100 billion a year, and if the estimated downtime is just 1%, that's about a $1 billion threat surface. The total cost of control can be really difficult to estimate. It includes the product procurement, planning, installation, and maintenance, including the skilled personnel, the operating costs. We have economic impacts, productivity, and business process impacts. And the control value itself is a reduction in the annual estimated loss, considering the cost of a control, such as MOSAICS. The true total cost can be 2 to 10 times the cost, the price of a control product. But I'd like to draw your attention to in risk identification and actual asset valuation, and being able to determine the quantitative cost as well as the qualitative or relative importance values. In the case of a substation, for example, I'd like to draw your attention, and it might be small writing, but I'll read it to you, to the transformer and capacitor replacement cost. If you're looking at a substation, a very conservative substation automation system can range 10 to 40 million, depending on the voltage level. That would be a lower end. If there were a damage to assets, so when you're looking at the quantitative value of your assets, a specialty phase shifter could cost upwards of $4 million. And most asset owners don't have transformers that are sitting anywhere that are easily accessible as a backup or that very portable as a backup. So replacing one of those assets, if it were damaged in any way by a potential cyber event, would be definitely impactful, and you're already looking at the values of those high value assets. So a capacitor or a phase unit, so it's in millions of dollars to replace that. So back to the potential consequences for a cyber event. Colonial's 5,500 miles of pipeline basically carry fuel from refineries from the Gulf Coast to customers throughout the southern United States. It transports, I've read 45% of the total fuel consumed on the East Coast, reaching 50 million Americans. So in terms of consequences, definitely impactful. A ransomware attack led to one of the nation's biggest fuel line pipeline operators to shut down its network, its entire network, and that happened in early in May. One of the things to point out, though, is that that ransomware attack occurred at the higher levels of what one might call Purdue model, at the higher levels, the enterprise levels, or the business functions. The perpetrators allegedly just wanted ransom. If you go back to when I was talking about the cost of the transformers or replacement costs of components, they were actually allegedly not targeting those damage to equipment, which could have caused a much greater interruption than we experienced. So here's where I'm going to get to a little bit of how we would do a quantitative risk analysis. If one were to look at just an electrical distribution substation, which is what MOSAICS was based on, a power system. So this is a power system. If we want to use commercial values, the control would be with MOSAICS and no control would be without MOSAICS. So we start by assigning a numerical value or cost to the assets, the actual assets, vice the typical qualitative risk analysis that we see for looking at whether we should impose a control or not. So that allows the cost-benefit analysis and a more clear and concise characterization of the actual risk. So we start with the asset valuation, a threat analysis, and a vulnerability assessment. We calculate the annualized loss expectance from a single loss expectancy and the annualized rate of occurrence. So ALE is SLE times ARO, right? And then we look at the asset valuation times the exposure factor. The exposure factor being a fraction of the total asset value potentially lost in a single event with a specific threat. And then the annual rate of occurrence would be the estimated number of occurrences in a specific threat within a 12-month period. So a lot of risk analysis parameters are estimated using published security data and event histories and expert judgment and so forth. So there are automated tools that are available, but this is kind of how a quick analysis is done. So when we look at this, we can see that if we had a control value estimated at a target value of about 6,000 a month, and where I came up with that number is, I think I didn't have a slide in here, is the MOSAICS capability without labor in just actual hardware and software cost came to about 6,000 per month in licensing to be the actual cost. So that's where that 6,000 a month comes to. And if we multiply that by the amount of months, we come to about 72,000. And then we're looking at about 10 million of a return on investment in the control. So a positive return on investment in the control, 10 million vice the potential of loss of asset. So now to the Colonial Pipeline example. So we're going to pivot from a power to a fuel example, but in this case, again, we're at the top levels of the Purdue model because it wasn't actually any of the assets that were targeted for damage, but it was actually at the business enterprise level. So the result is a positive return on the investment in the control. Looking at that ransomware attack, this is where I want to take you back to when I was mentioning to pay attention to the 5 days. That ransomware attack caused Colonial Pipeline to shut down their businesses from 7 to 12 May, or 5 days of downtime or unavailability of the product or service. In the case of Colonial Pipeline, they made that decision because they didn't want the potential for damage to the equipment or damage or loss of life. So it was critical to clean the system of any cyber vulnerability that existed from the ransomware. Now, the annual revenue of Colonial Pipeline is approximately $5 million. They pump about 100 million gallons of fuel or 2.5 million barrels per day. Again, impact of mission, 45% of all fuel consumed on the East Coast, and it serves more than 50 million Americans. So clearly it is of a civilian interest, but also for the Department of Defense of high importance. No fuel, no fight. So we need to have fuel and the ability to project force. That single ransomware attack, we took the cost of the 5 days, the 2.5 million barrels, and we basically looked at what the crude oil cost was per day. Because again, we were looking at a quick quantitative, what does it cost a business? And is there a return on investment to be able to reuse or apply a capability such as MOSAICS? And we looked at that, and the impact for the sales for Colonial Pipeline, it impacted 812 million. So in terms of revenue, that was definitely a high impact. Using the same type of calculations of with no control or with the MOSAICS control, and using a very conservative, or at least I think it's conservative, saying 2 attempted attacks per year, a countermeasure target cost, such as a MOSAIC capability, of 6,000 per month, estimated, again, a very conservative, to reduce the loss to, I don't know, 0.002% of the annual revenue. So if you use those very conservative numbers and you calculate it out, you come with a positive return on investment of 20 million. So approximately 20 million, which is what was also already invested for the early development. The other piece about it is, in the case of Colonial Pipeline, that was just a one sector attack. What about cascading effects of multi-sector attacks? Or what about both the East Coast and the West Coast percent of fuel consumed? Cascading loss of manufacturing, transportation, and business revenue could run into the trillions. So the return on investment for just one company, one event, and one sector. Colonial paid $5 million to get the decryption tool and paid in cryptocurrency, which is quite the bargain against the potential impact of continuing loss based on ransomware. But what about something like a MOSAICS capability of control that would prevent such ransomware attacks? So if it was detected, which is step 1 to containing it, to containing a ransomware attack. So in general, having these executing outside of a baseline of a system would stop the ransomware attack from executing in the business system. Calculating that out would definitely have been advantageous had such a control been used in the Colonial Pipeline example. So again, the malicious actors claimed financial gain to be their objective, not physical damage. But if we had put in the asset values of the physical damage that could have been done, it would be considerably higher. So it's a big systems engineering challenge if you look at all the assets across the United States and the potential for the consequences. And that is my overview of the cost of the countermeasure exceeding the cost of the risk. Thank you for giving me an opportunity to share those thoughts.
Thank you, Aleksandra. So if folks feel free to unmute yourselves if you want to, if you have questions you'd like to ask Ms. Scalco. Feel free to unmute yourselves. Do we have anyone want to start us off? While we're waiting, I did have one that just sort of recently occurred to me. Is do you have an idea of maybe you had gave sort of a history of sort of the ramp up of the awareness of how these systems are so vulnerable and stuff. I was wondering, is it just the U.S. or are there other countries that may have been more responsive earlier on with this?
I don't know about, by more responsive, do you mean already have solutions or more affected,
well,
already having been affected?
I guess, well, whatever you want to answer, but I guess what I was asking is I guess if they've got an earlier jump start on creating standards that they apply and regulations that they apply to get their systems that they have in place more up to date. in respect to handling vulnerable incidents or whatever?
Oh, that's a great question. And the answer, it is a global challenge. It's truly, we've seen some of the events such as Stuxnet in 2010. Well, that was very specifically targeted. It was a very sophisticated attack that specifically targeted industrial software equipment for uranium enrichment at the PLC level or at the lowest levels. So that was a very specific targeted attack or event, one might say. Other ones, there was Night Dragon, and also in 2010, that was targeted global oil companies, and they have continued to see similar attacks to disrupt fuel supply. Again, that would affect our global fuel supply. Shamoon was, again, energy companies in the Middle East. But I think some of the ones that you're asking about is 2015. That was the coordinated cyber attack on Ukraine power utilities, where power was cut to the population. So we're definitely seeing these type of events on infrastructure globally, and there has not been a tremendous amount of advancement in how companies might or organizations might share information. There's certainly going to be standards evolving. We can look towards the MITRE attack framework is something that is now being used and applied, so that we're able to look at the MITRE attack framework in terms of where there are vulnerabilities and what might cover the vulnerabilities. But a lot of the systems that we're talking about, like when we're talking about the Bowman Dam in 2013 in New York, there was an attack on the Bowman Dam. A lot of this infrastructure was built to last a long time, which was very wonderfully effective. So we have infrastructure that has been around really before we as systems engineers could conceive of the cyber connection. And now we're also are seeing there's the business, the economics of the potential for cyber connections. So we're basically adding capability or adding something to systems that weren't really designed for functioning with thinking through what a wireless connection might be or remote access. And that was further another further challenge was from the pandemic. And I don't know that we're ever going to put that Pandora back in the box, is that we've had 2 years of telework and needing to have really leverage remote capability. So that's really demonstrated this remote capability that we are globally using without having caught up the systems engineering practices or those solutions. But MOSAICS capability is one of the first. I'm not aware of any other ones that are as equally advanced. Dave Flanagan, one of your members at APL, was absolutely pivotal. He was one of the senior leaders on that effort. And we really now are looking at, it's been demonstrated, and are looking at sharing that capability out and allowing systems engineering to advance it.
I think, thank you, Aleksandra. I think Greg Opus has a question. He has his hand up. Greg, you want to unmute and ask your question?
Hi, Greg, I don't hear a question yet.
Yeah, I don't hear anything.
I think it's just a high five.
Oh, is that what that is? High five or?
Greg, you want to put that in chat maybe? Let's see.
Yeah, if you have a question, put it in chat there. Otherwise, Jeff has his hand up too.
Yeah, Aleksandra, I like the I liked your presentation. Really interesting material. I've got a question for you about the emerging Internet of Things technologies and how those will be embedded not only in utility platforms and systems as you were covering today, but even into transportation and medical, and very concerned about the ability of cyber attack in transportation or hospital settings or home care medical settings. It's one thing to take away energy or take away lighting, but to attack these other sectors of our economy that might be very life-threatening. I just don't understand the why those sectors haven't been attacked yet, and also what kind of warranty and liability come from the product vendors. How much are they at stake when these unfortunate events start to happen in these other sectors?
Thank you for asking, and they have. So I don't want to tell you incorrectly. It's been in the last month, but lately days kind of blurred together. So thank you, Jeffrey Burlett, for asking that question. In the transportation sector, absolutely, there have been ransomware attacks, and also in the agricultural sector, so food security. And recently, one of the largest companies that supports some incredibly significant percentage of the farm equipment and enterprise business to support farming and agriculture was hit with a ransomware attack. And we have seen those in public news for hospitals as well. I think you touched on a couple of issues we've gotten very good at HIPAA and PII, right? The personal identifying information and protecting really I think we have been understanding the IT transports data, but moving that same type of security to the physical systems. So in a hospital, the lifelines become very important. So when you look at a hospital being affected by ransomware, is it a terrible inconvenience if someone's PII is shared? Yeah, I would, as someone who's visited medical facilities, absolutely. But more importantly, our hospitals depend on those lifelines. Without water, in 72 hours, you start to have loss of life. Without power, we lose dialysis patients within 7 days. So those lifelines, they have high dependency between the verticals in each one of them. So healthcare systems absolutely is critical, and during the pandemic, even more so. But it's not just being able to access and support patient care data or information. It's the ability to save lives and to maintain life. And those start having it's a very fragile relationship very quickly when we're looking at the lifeline services such as power and water and transportation, which would be the ambulance services to be able to transport someone in an emergency to where they need to be to get the care they need. Over.
Thank you.
It looks like Greg was able to get his question in the chat there, so I can read it here. He says he loved the approach and had a thought about the establishment of the frequency of attacks for the calculation approach. He used to support JIEDDO, J-I-E-D-D-O, with some work using attack tree methodologies, which combine fault tree characterizations with motivations of attackers to do harm, and their capabilities and resources to do so. Admittedly, this requires deeper and deeper assumptions, but could be a nice way to amplify the assessment of likelihood to help those who might still wish away the problem space. So it sounds like he had a comment there more than a question, but
it is a question comments.
Okay.
Comments. I get it. And yeah, I think that Incose and the Critical Infrastructure Protection Working Group, the Resilience Working Group, I believe there are a number of other working groups. I think there's a Smart City working group as well. I don't want to say incorrectly. And I know that Erica Palmer is leading a socio-technical working group. It just absolutely would be phenomenal for Incose as a global organization to really start arming our systems engineers. We do have the tools. I mean, the systems engineer, MOSAICS as a capability was a systems engineering demonstration and accomplishment. So some of those approaches that you're describing to really start, I have a high level, hey, it's, not doing this is not going to be a good thing for anyone. But as systems engineering, how do we get down to the tools? And even I know in the control and the critical infrastructure protection working group, Tony is leading a phenomenal effort on, I've seen him starting to map in that working group, in SysML, in Cameo, using Cameo, what those interdependencies are between the verticals. And I think that we collectively, we as Incose can do a tremendous amount to start influencing and suggesting through CBOC, combining between the resiliency working groups and the critical infrastructure protection working group to ensure that systems engineers that go forth and work on any of those systems that touch the physical world are better armed and have a better understanding and appreciation of what the cybersecurity vulnerabilities might be and what tools we have to ensure that we're designing systems to withstand and be resilient against whether it's an event because someone by accident or just not knowing fell victim to a phishing attack and caused an outage, or if it's an actual equipment failure connected. I think that we can do better and provide the systems engineering thought leadership to help everyone better secure both the legacy systems as well as the new systems design going forward, and ensuring, going back to the GERD, the Grand Ethiopian Renaissance Dam, is being able to also look across socio-technical systems and understanding the potential impacts for upstream and downstream from those infrastructure systems that we design and develop. Over.
I think, Greg says, thanks for taking that as both a question and a comment.
Good one, yeah.
The slides will be available, yes. So she has already sent me her slides, and every, Greg, every talk that we do, monthly members meeting, is published as an action after report on our website, and we always provide the slides as well as we record the talk in video, and there's a link to our YouTube channel that will then show the video, so you'll have access to that. Also, it looks like Mr. Alabayati has a question, and he says, what would be the best practices for convening companies or people of the cybersecurity and the impact of cyber attacks? My question is mainly for companies who do all the communications with old-fashioned paper and equipment are manually controlled. Old-fashioned and equipment are manually controlled.
That's awesome. That's a lot of our equipment, right? So I guess best practices, I would point, it's available on the internet. US Cyber Command put out ACI TTPs, so Advanced Cyber. Oh, Dave Flanagan, you might have to help me with this. I'm going to call on a friend. I know the tactics, techniques, and procedures, but it's called the ACI TTPs. Do you have that, Dave?
Advanced Cyber Industrial Control Systems, Tactics, Techniques, and Procedures.
Thank you. I like that acronym better, but thank you. Thanks, Dave, for the save. So the ACI TTPs basically provide a manual process for responding to anomalies that might be cyber anomalies. So those are available as manual process, the manual process for response. And in MOSAICS, started to down selected and identified those that were high candidates for automation and introduced semi-automation for those processes. But for companies and equipment that are manually controlled, there are a couple of things. Is one, for those operators that are working on the system, I think that they need to there needs to be cybersecurity training, period. for all of us. In the United Kingdom, they do some very interesting, we have CISA in the United States, right? Department of Homeland Security. In the United Kingdom, they really have taken an interesting tack where they're trying to get every citizen cybersecurity aware or trained. And they really want to have that anyone, regardless of age, such as, you know, a grandmother, would be able to understand cybersecurity fundamentals. They've really been campaigning to raise cybersecurity awareness, that the rising tide lifts all ships. So similarly, if I were working in a water treatment plant, for example, I think that we need to start looking, our safety engineers are, you know, highly skilled, you know, our engineering systems are about personnel healthcare and welfare and safety, and are very safety focused in ISO. And we just need to start introducing that cybersecurity, and that there are vectors, and to introduce some just fundamental cybersecurity training and make them cyber aware. We need to stop thinking that the IT department handles IT and that OT doesn't touch IT, and that OT may only touch the manual systems. We need to make sure that the IT and the OT make friends, right? And support one another and go through training together, so that those that are running our IT systems at the business level understand what the mission is, understand what the manual systems are that are controlling the physical world. And then similarly, those operators that are, you know, maybe a safety engineer, a control engineer, are just informed of what the cyber vulnerabilities might be. And then I wanted to add one more thing to that, is just yesterday I was in a panel in Resilience Week, and Dr. Steve Simsky from Colorado State University, he shared, hey, we have to also quit being mad at people for being victim of a phishing attack, and need to start understanding that not everybody is a cyber geek, or I don't know that those are the words he used, but isn't, you know, just this cyber savvy. And we need to start designing things so that when a product comes out of the box, you might be doing everything manual, but if you have a product, any type of product, if it's on your network, that it comes out of the box and does not have the default password, for example, make it come out of the box so that somebody actually has to put in a new password. So there, you don't have a default password anymore. So there are things that we just have to stop being mad at people who aren't cyber people for falling victim to things that are best practices, or that we would want to have as best practices, and start designing as systems engineers so that those mistakes aren't so readily made. Over.
Yeah, I had one final question. It's kind of like similar to my other one. It's like, are there industry leaders in you know, control system security? Like, it seems to me like, I don't know, maybe like the finance industry might, you know, be very risk conscientious of these things, and they might be one of the leaders. Is there any one industry sort of that sort of seems to be more sensitive and leading the charge here?
So I'm going to give an answer that is, on the one hand, I was just sharing how woefully needed we need systems engineering, and we need to have security practices. So thank you for that question, Jeffrey Burlett. But on the other hand, we have really phenomenal knowledge base that's really just understand that we have a lot of systems, right? But we do have a phenomenal knowledge base. I'd like to highlight that what MOSAICS, the Joint Capability Technology Demonstration, a huge component of that was developed out of APL, when APL, the Applied Physics Labs, was leading Integrated Adaptive Cyber Defense, or IACD. That was funded by the National Security Agency and Department of Homeland Security. But it was really APL that started driving a capability of orchestration, security orchestration for IT enterprise. And after successfully, and you can find that on the internet, wonderful just tools and information on how to secure your IT, which definitely goes hand in hand with the physical. Then there was the challenge question of, oh, can this capability be applied to a control system or a physical system at the lower level? And that was the kind of genesis for this particular JCTD as well. So the IACD was piloted, I believe, in the financial industry. Dave Flanagan can talk more about that, and I think it would be a phenomenally interesting brief to hear about the IACD and what was achieved and accomplished in the financial industry. Clearly, they're better funded than in government when we have to ask. I mean, it's kind of, I don't know that it's the highlight of anyone's life if someone comes and says, hey, we need some funding to secure our wastewater system. Or if someone comes from a financial sector and says, you have a credit card with me and I'm looking to ensure the financial transactions. So there's also different liability levels. And I don't know that those standards and policies and liabilities and insurance companies have really caught up with the potential impacts of a devastating loss. Over.
Okay, thank you. So now I'm gonna share my screen again. Let's see if we can, there we go. Just want to give you this sort of virtual certificate of appreciation. I'll get you an emailed copy. Normally when we have live events, we actually give it to you in a framed presentation format, but I just want to formally thank you. Excellent talk, and we really appreciate you showing up and talking for us.
That means so much to me. I appreciate that. Chesapeake chapter is an important chapter, so that means a lot to me. Thank you.